We're going to solve this simple question, which goes like this. That saying a bullet of a 5 gram bullet is fired horizontally into a 7 kg tube of wood, which is at rest and sticks in it. The tube is free to move and has a velocity of 40 centimeters per second after impact. Find the initial velocity of the bullet. The moment you see something like this stuck together and they started moving as a whole, what should always come into your mind is okay. So to calculate for the initial velocity, the question is straightforward. We say only linear momentum is what conserved, right? Meaning that what we are going to do, and how do you write the formula for the same type of collisions? For elastic collision, we understand to say the summation of initial has to be equal to the summation of what? The summation of the final momentum. Meaning that if you have two particles, particle A, the other one is here. If this one is the one which is moving with the initial velocity, this one is at rest. Meaning that this won't have the linear momentum due to the fact that it is initially at rest. So what we are going to do here, this is going to have momentum, even this one is going to have momentum, though it will be having a zero momentum. So the meaning of summation of momentum here, it simply means this one, which is particle A and particle B, they are going to have their linear momentum. Even here, they will also have their linear momentum. That is according to what we call elastic collision, whereby they do bounce off each other. So we are going to have, on the part of initial, we are going to have mass A multiplied by the initial velocity of particle A, I'll say plus, mass B multiplied by the initial velocity of B. This has to be equal to, you say, mass A multiplied by the final velocity of particle A. Sometimes here they use, some people they use the prime, whichever, but what matters the most is the value you are going to what to get. If you don't want to write like this, you can even put it final A. You can even write it like A. It also gives the same thing. So I'll say plus mass B multiplied by the final velocity of B. The only difference between the initial, I'm putting a zero before that same thing. So since this one is having a zero momentum, we're going to cancel it based on the description. But this has to be the actual formula you're supposed to use the moment you're dealing with what we call elastic collision. If you are dealing with what we call elastic collision, this has to be the formula. If you are dealing with what we call inelastic, some people they say perfect. Inelastic. What we are going to do is this. Since we are dealing with perfect inelastic, meaning that here our thing is going to be, we have to know what are the things that are being conserved here. Even at this instant, you need to understand to say the formula for momentum has to be the same one which is here. Remember, we don't have kinetic energy being conserved here. Here we have kinetic energy being conserved, meaning that let me try to write another formula for kinetic energy. This can also help us calculate for velocity. We are going to have 1 over 2, I'll say mass A multiplied by the initial velocity of A square plus 1 over 2 mass of B multiplied by its initial velocity square. This has to give us 1 over 2 mass of A multiplied by its final velocity square plus 1 over 2 mass of B multiplied by the final velocity of B. These two formulas can be used if they ask you to say, can you calculate for the initial velocity or final velocity of whichever particle you are going to have in that same arrangement. So these two, they apply to what we call elastic collision because we are saying linear momentum is conserved and kinetic energy is also conserved. If you come to what we call inelastic, Inelastic collision. In some books, they even put perfect inelastic. It's just one of the same thing. So since only linear momentum here is conserved, what should always come into our minds is we need to know that if linear momentum is conserved, one thing is experiencing momentum here. Only a single thing. And what is that? A particle is experiencing momentum, meaning that I'll say momentum. Here we don't have a summation because only one thing is going to be experiencing what we call momentum. So this one is going to be equal to, you say, mass of that same object, open bracket, the final velocity minus the initial velocity of that object. Why am I trying to write it like this? Because this type of collision mostly involves a change in momentum. It mostly involves a change in momentum. Okay, now what about the issue of perfectly inelastic collision? Perfectly inelastic collision. So under perfect inelastic collision, what we have to understand always is that this is a type of collision which involves the sticking together of two objects and they start moving as a whole. Now, I'm giving us already the example. If you shoot a bullet into a wood, you'll find that sometimes the bullet can stick into that same wood, then they can start moving together. So that is a simple example that we have to understand. The moment they start moving together, meaning that that will not be perfect inelastic collision. It has to be called elastic collision. Why? Because two objects they are bouncing off each other. The one is going to go in the other direction. It's impossible that if the bullet goes like this, then you expect that it will still take that same path. You find that sometimes it can go, then it will do what? Move in the direction. Then this one can also go in the other direction. Or the one which is a target here, if a bullet shoots it at this given point, it can make this one even come in the opposite direction, then the bullet is going to go in the other. Okay, so they're saying a bullet is moving. A bullet is moving towards the wood. So what we are going to understand, do we have the initial velocity of the bullet? The answer is no. This is going to have V initial, V. Do we have the initial velocity of this? This one is at rest. Yes. Meaning that if initial velocity is going to be what? Like this, right? Then you come to their final velocities. These two are going to stick together. The blade will go in, then it's going to have something like this. So they will start moving together now. Meaning that what we are going to have as the final momentum, which is final momentum, we won't have separate things here. How are we going to display this? We are going to have momentum multiplied by, mass multiplied by the final velocity. So if you check these two, they have two masses, the mass of the bullet and the mass of the wood. Meaning that where there is this, I'm going to write mass of the bullet plus mass of the wood. They have to be multiplied by the final velocity. Why? Because they are moving as a whole. Now, so we are going to have something like this. We are going to have summation of momentum has to be equal to summation of momentum on the part of final and the part of initial. Okay, so we have to expect something. Initially, these two they have separate momentums. Why? Because this one is moving, that one is not moving. So we are going to have mass of the bullet multiplied by its initial velocity plus mass of the wood multiplied by the initial velocity of the wood. It has to be equal to. Here you have to get this and place it at the final because the two objects are now moving as a whole. So we are going to have mass of the bullet plus mass of the wood. I will do this. I'll close, then I'll say find velocity. This has to be the special formula you're supposed to be using. But get back to this. We don't have the initial velocity for what? For the wood. This one is going to give us a 0. So definitely, the formula we are going to use for us to find the initial velocity of the bullet has to be the mass of the bullet multiplied by the initial velocity of the bullet equal to, we say, mass of the bullet plus mass of the wood. We have to multiply this time the final velocity of both of the objects. Why? Because now they are going to be moving with the same velocity. If you get back here, we want to calculate for what? For the initial velocity of the bullet based on the question, I'll divide throughout by mass of the bullet. Even here, I'll also divide by mass of the bullet. These two, they are going to be cancelled. We are going to have the mass of the bullet, which is going to be, say mass, sorry, the initial velocity of the bullet has to be equal to mass of the bullet plus mass of the wood. We'll do this, multiplied by their final velocity over the mass of the bullet. So you need to be very careful because mass has to be in kgs, even the velocity has to be in meters per second. Now if you get back to this, they're saying a bullet is having 5 grams. I'll try to convert 5 grams into kgs. I'm going to have a kg there divided by 1000 grams. So this is going to give us 0.005 kg as the mass of the bullet. If you get back to the velocity, their final velocity has been given as 40 centimeters a second. It has been given as 40 centimeters a second. So we should also be able to convert this one into meters a second. So we are going to do it like this. I'll say 1 meter has to be equivalent to 100 centimeters. So this one is going to give us the final velocity for two objects after sticking together as 0.4 meters a second. Come back to the formula itself. We are going to have the final velocity, sorry, the initial velocity of the bullet has to be equal to the mass of the bullet, which is 0.005 plus the mass of the wood, which is 7? Yes, 7. I'll close. Then I'll say multiplied by the final velocity for two objects, which is 0.4 divided by the mass of the bullet, which is 0.005. So what we are going to understand here is this. If you are calculating for the initial velocity of the bullet, always the initial has to be greater than the final. Why? Because the speed of the bullet is going to be reduced due to the heaviness of the mass of that same thing. So this, the velocity you are going to get here, sometimes it can be 100, maybe 200 something. Why? Because you know the speed of the bullet, the way it moves. So you have to make sure that you get its speed, which is going to be greater than the final, the two they are having. What is the initial velocity of the bullet? 550. I'll just write it like this. So this was the initial velocity of the bullet and it was moving. If you check, there is a very big gap in terms of the mass. This is 0.005, but this is what? 7 kg. The possibility of the initial velocity being reduced to that will be very, very